So if at this point we could have created this mutex object and designed the mutex class to do the right thing, so that there are basically three things that we need: be able to create it, be able to acquire it, and be able to release it. And by the way, acquire means is that when multiple threads attempt to acquire, only one will succeed, and as it's still being acquired, all other threads, not necessarily 2, but 3, 4, and more, will just have to wait before they can acquire. So therefore, this is like a blocking call. They will essentially stop here, and they will have to wait and wait and wait and wait till another thread releases it, and so only one thread at a time can acquire this mutex. So again, this is something that we're going to add, this concept of mutex, and this time we can go as low as possible to the library level and use whatever resources we want to make this happen. So over here, I'm going to say I need my mutex, and this will be our mutex class. And in this mutex class, what I'm going to do is just do typical decoration right here. So basically, what I'm going to do is there is this Java util concurrent package, which stores, or provides a bunch of very useful synchronization objects that help multi-threading, programming. And one of them is called basically, or there are different types of concurrent objects there. There is a set of locks over there, which is pretty close to what we're trying to do. And there is a lock interface, okay? The interface lock, and you can read over here. Lock implementations provide more extensive locking operations than can be obtained using synchronized methods and statements, because they allow flexible structuring, may have quite different properties, and may support multiple associated condition objects. So in other words, it's, you can read the entire description here, and you can also, of course, read documentation online. But the most important one is that there is a reentrant lock, okay? There is a lock that I can create as basically going right here back to this package, and it has in this package there is a method called reentrant lock, which basically creates that type of lock. Let me make, of course, this is going to be our static, right, and private data piece. Lock, we're going to name this, we can, I'll just call it lock over here, right? Lock equals this concurrent lock. And one second. All right, so I will just rely on this new reentrant lock, which is one of the implementation of the lock synchronization objects in Java. And I really don't need much code for the constructor inside my mutex, because again, I'm relying on the static data piece, which I capture as an interface. I call it lock. And then if I move this to the to another panel. Remember, I want to have this acquire, right? Acquire method. Acquire method will simply just be a void method that doesn't return anything, right? Acquire. And I will also need another, so this will be public, right? And I also need this public release, public void release method, which will basically, in both will simply use my lock, right? I have my lock right here, and I will say lock. I think there's a lock method in there. Yes, lock. Lock will acquire the object, and the other side lock unlock. Yes, unlock will release the lock. So this looks a little confusing. So I'm actually going to call this static piece reentrant lock. This will be better name for it and less confusing to look at this. So over here I would just say reentrant lock. I think that would be a better choice for naming over here. So let's save everything. Let me see. What we can do here is try building this and see if everything builds. So everything builds, and if I go back to pick at my main method, we still have our get instance, but this time when we go inside Singleton and get instance, we should have a truly well-established critical section, which is now protected in case if we do have challenge in multi-threaded systems, multi-user, multi-threaded systems. So every thread will have enough safety accessing this instance. And I mean, again, in my test, I'm just going to run it. You can see that, of course, the hash codes that being produced by both of the Singleton and Singleton 2 are exactly the same. So the runtime environment allows us to run this pretty well. And so that's my choice for this type of implementation. Let me just highlight everything that I did so far in the sample, right? So just a quick overview of what we did. Number one, we designed the Singleton class, right? And so the interface of the Singleton class contains, basically, we have a private constructor. Usually in my UML diagrams, I display constructors using the new, not name of the class as we do in software, but actually using the keyword new and making it private in this case. And the second piece here is get public, get instance. Right? And that get instance returns an instance of the Singleton, right? So the idea is that we would like to prevent the users to instantiate these objects unless they call get instance, right? So only through get instance they can accomplish to obtain reference to our Singleton class, which supposedly that's right. The constructor and get instance, there are two methods over here, right? So that's what I made part of my Singleton class, right? We of course internally keep the instance over here. So there's a private instance over here, and we have this critical section inside get instance which protects creation of new singleton and guarantees that only one of singletons will be created per lifetime of this application.